So let's talk about some valid arguments. And so we've stepped through some logic, but we're moving towards proof. So we're trying to move to the point that we can prove that something is true based on information provided by us. So first of all, we have to understand what does it mean to establish some facts within an argument, and what even is an argument. So an argument is just going to be a sequence of statements, premises, and this can look like propositions, and then we're going to put those propositions together, these premises together, and try to draw a conclusion. So we're going to have a sequence of premises that are going to end in a conclusion, a sequence of statements that we're declaring as true, and then from those we're going to arrive at some conclusion. And this is what happens when you have, just a conversation with a friend. If you have an argument, and I don't mean this in the negative way, but if you're having a discussion and trying to convince somebody that your belief is true, you state a bunch of things that you hold as true, and from that you draw a valid conclusion. So you draw a conclusion, and hopefully, if you argue logically, then the conclusion follows from your premises. There's an important piece in that, and sometimes you'll have a discussion with someone, right? And they're trying to argue their point of view. And what happens is they list their premises, which are the things that they hold to be true, and they arrive at a conclusion, and for them it makes complete sense, right? This is what I believe to be true. This is the conclusion. Sometimes we disagree on the premises. So a valid argument is one that if the premises are true, the conclusion follows. And you can have a valid argument that leads to a very specific, so the premises lead to a conclusion, but an argument is valid if it's impossible for all the premises to be true and the conclusion to be false. And what that doesn't say is if somebody has premises that happen to be false, the conclusion might not be true. And we'll see what that looks like. I think of a look at valid arguments as kind of a gateway, a bridge between logic and proof. And logic and proof are very tied together. And so this is our bridge to proof. We're still hanging out in logic, but we're heading over towards proof. Okay, so we're going to look at arguments that involve the things that we've been working with. They involve compound propositions. And then we're going to learn how to reason correctly. And we're going to learn some rules about how we're allowed to reason. Then we're going to apply those rules. These rules are called the rules of inference, to all the types of logic that we've learned so far. So first to propositional logic today, and then to predicate logic. And in doing this, we are going to create valid arguments. And then, more importantly, we're going to be able to learn how to identify if somebody is reasoning correctly, or if what they're doing is providing an invalid argument, if their argument for something to hold is just blatantly wrong. Okay? All right, so I want you to think about this. Is this valid logic? If it is a Wednesday, then we have class. It is Wednesday. Therefore, we have class. So these are my premises. If it is a Wednesday, then we have class. It is a Wednesday. And those are premises, but they're also propositions, right? So they have a Boolean value. If it is Wednesday, then we have a class. It is Wednesday. Both of those are propositions. One is an atomic proposition. The first is a compound proposition because it says if it is Wednesday implies there is a class. We have a class. Okay, so we have, if it is Wednesday, then we have a class. That's our compound proposition. And it is Wednesday is our atomic proposition. I can't break it down into conceptually smaller ideas. Okay, so those are the premises. And I'm claiming that therefore we have a class is our conclusion. So we have premises and we have the conclusion. Therefore we have a class. Is this valid logic? The majority of our class so far is feeling that this is valid logic. And I'm going to say, I agree with them. However, I can also understand why you'd say no. And I'm going to come to that later. So both of those are really appropriate ways of thinking about things, and there are reasons that people might feel otherwise. For instance, if there was a hurricane and we had this almost happen, theoretically happened when Teddy came through, it's possible that we don't have a class on a Wednesday, despite the fact that there is this idea that if it's a Wednesday, we have a class. Because if that premise was false, then the whole thing falls apart, right? So if you said no, that might be where you're going. But if you said yes, it is valid logic. What I agree with is that this is a valid form of an argument. If these hold, then we absolutely do have a class. So if it is true that if it is a Wednesday, then we have class, and it is a Wednesday, if the premises are true, the conclusion follows. And this form of an argument looks like this. Okay, so if these are our compound propositions, P implies Q, and that is, if it is a Wednesday, then we have a class. So in this case, P is, it is Wednesday, and Q is, we have class. Then what we see is that this is one way that we can represent this. It is Wednesday implies that we have class. That's just the compound proposition way of presenting, if it is a Wednesday, then we have class. And then P would represent it is Wednesday. And this little symbol right here, it looks like a stack of objects. This means therefore. And so what this is saying, and this is how we represent this notationally, we say that we've got a set of premises and we just stack them on top of each other. We put a line below, and then that therefore is the conclusion that follows. Yeah, so it's premise, and possibly more, premise, and then this means therefore, and then this is our conclusion. So the question was, is this a valid argument? And I'm saying it is, but I should prove that to you. I should show you why I believe that to be true. So I assume that the premises are true. So I assume that, and this is an important piece, I'm going to assume they're true. So I'm going to assume that P implies Q is true and P is true. Well, if I could show that the fact that these two are true implies Q is a tautology, meaning no matter how I fill in, so the way that I think about it, I mean, the first way that we've seen that we look at it, this is we've got our truth table, and if I can show that when this is true, no matter what I do, then Q is true, that's saying it's a tautology, right? Then I know that I can assume that Q is true if I know that these two are true. And that's a valid argument. Because really when we have an argument, we're saying, you know, I assume that P is true, I assume that P implies Q, and from that I'm going to argue that Q must also be true. Okay, so the question is, does it follow then? And the one way we could do that is to look at the truth tables, and we've done that before. But we can also step through it as follows. So I can represent, I know that if I look at P implies Q, is there another way that I can think of what that means? So what does it mean to say P implies Q? So I can also write that as not P or Q, because either P is true and so Q must be, or P is false. So that's the same as not P or Q. I'm assuming that both P and P implies Q are true. So is there anything you can tell me about this? If P is true, then not P is false. And so I can actually replace that not P with a false. So now what can you tell me then about false or Q? So that's this piece right here. If I have something that's false or something that's Q, what is the truth value of false or Q? It could be false, but it does depend on Q. And that's because we can actually say, well, if Q is false, the whole thing is false, right? So if we have false or false, that's equal to false, right? But if I have Q as true, false or true is equal to true. And so in this situation, it entirely depends upon Q. And so what we can actually say then is false or Q is the same as Q. We can actually say we don't need to worry about the false, we just keep the Q around. Okay, so now I've got Q and P. Can anybody identify how I can reduce this even further? And I'm just going to point you to one line. So we have assumed that P is true, right? So now we've got Q and P. And this one is true. We've assumed it to be true. And so that's like saying Q and true. So now what does this depend on? What is it equivalent to? So if we look at that P and Q, is that the same as just P, the same as just Q? It's always true, it's always false. Because in an and, for this to be true, so the way that you can, if you don't remember the logical equivalence, which is the same as saying Q, you can think of, well, what happens if I let Q be false? Well, false and true, for an and to be true, they both must be true, right? And so since Q is false, the whole thing would be false. If I let Q be true, well, true and true is still true. So what happens is, so that was our intermediate step. First we say, okay, well, that's the same as Q and true. And so the whole thing is just equal to Q. And what that means then is if I were to go backward, when I start from if it is Wednesday, then we have class, it is Wednesday, therefore we have class. This holds because if we assume this first premise is true and we assume the second premise is true, then no matter what, Q is also true. And so we've shown that P implies Q and P. If both are true, then Q is also true. So we showed that this whole statement there is a tautology. It's always true. And so this is how one actually proves that a valid an argument form is valid. Okay, and so that showed us that as I just wrote there, P implies Q and P implies Q is a tautology. It's always true. And so this form really matters.